Good day, good day, good day, everyone. And once again, we are back together. All right, let's look at the galvanic cell this time around. Just a quick revision and a walkthrough. And of course, if you haven't really watched our long long videos on this section, do yourself a favor and do that. Okay, right. So let's have a look at the cell in particular. So we're given there. Okay, let me just try to zoom out. They say the galvanic cell represented rather in the diagram consists of a barium electrode dipped in barium nitrate. Okay, that's the electrolyte, and copper electrode dipped in copper nitrate, which is the electrolyte, right? Assume that the cell operates under standard conditions. Right, now they say to us, first of all, state two of the standard conditions. Now, obviously, there is no guess in this case, so we only will mention the two. So the first one is that the temperature, okay, so temperature must be equal to 25 degrees Celsius, so you can say room temperature, okay? And in this case, the concentration of your electrolytes, okay, which is your barium nitrates, barium nitrate and copper nitrate in this case, so must be equal to 1 mole per cubic decimeters. Obviously, that should be the initial concentration, right? So those are the two standard conditions. Okay, so if we have a look at that now, the next question they say to us, write down the half reaction that takes place at half cell A. Now, what I'm going to do quickly, remember, I always kind of do this part first and then I answer the question. So I'm going to follow the very same thing and then we can answer the questions afterwards. Okay, right. So we said we've got barium, all right, in this case, as well as copper. So I'm going to go to my standard reduction potentials table and look for barium. There it is right at the bottom there. It's negative 2.9. And copper, now remember they said copper 2, right? Remember, so you've got copper nitrate. You see there's a 2 there at the bottom, right? So that 2 at the bottom simply is telling you are taking copper 2 plus and copper 0. So in that case, that's the one there for positive 3.4. For some odd reason, this thing is just, yeah, it was a little bit blurry. Okay, so there's that copper 2 plus there to copper 0 with 0.34, right? So I'm going to draw a number line and say, okay, so we've got negative 2.90. Remember, you write it in ascending order, right? So negative 2.9, that's for barium. There it is at the bottom there. Okay, so now what do we say? We say, well, we write it in ascending order and we ask ourselves the question, all right, which parties in government? Okay, the A and C. And what does that A and C do? Well, they give away houses, right? But obviously, they've been infamous for other things, but nonetheless, right. So in this case, we're going to say now, it means that, remember, this side is for barium, that's the negative 2.9, and this one is for copper. So in this case, it means that barium is the anode and copper is the cathode. Okay, so it means that barium is giving away electrons and copper is the one that is using electrons, or in this case undergoing reduction. Okay, right. Now so remember, the one that's the anode, I'm going to take the half reaction, barium, okay, take the half reaction, okay, and in this case, well, first of all, I should have written them exactly as they appear. So that's barium 2 plus 2 electrons. That should be with double arrows. That's minus 2.90. and copper 2 plus 2 electrons would give me copper, and that's positive 0.34, right? Let me just take this right down there. Okay, so we said the one that's the anode, you always take the half reaction and you write it in reverse, right? So that's barium. It's going to be barium 2 plus 2 electrons, okay? And of course with copper, it remains as it is. The other one, you write it exactly as is. That's 2 electrons. That will give us copper, right? Now what you need to do is to make sure that the number of electrons is balanced, right? That means they're exactly the same, and it is the case here. So I can actually remove the electrons, and what do I have at the end? For my net cell reaction, I'll have barium plus copper 2 plus, which will give me barium 2 plus copper. Okay, so I write everything that's on the left hand side of each equation, and that's the net cell reaction that I will have. Okay, right, and now let's answer the questions. They say to us, write down which half cell, A or B, is the cathode. Okay, write only A or B. So we've already seen that. Which one is the cathode? Okay, of course it's going to be half cell, or it's B in this case. Okay, so they said write down A or B. Please don't write, follow the instructions, right? So don't say half cell B. They just said write A or B, right? So that's 8.3. Let's look at 8.3. What are they looking for? They say write down the half reaction that takes place in A. So A, in this case, would be... Now, how would you know what A is? So look at this. Look at the direction of the electrons, right? So it means A, this is where the electrons are coming from. This is the one that's giving away electrons. So if you remember our diagram there, so which one is giving away electrons? So it means barium is half cell A, right? And of course copper 2 plus, copper is the second electrode, half cell B. So they said which, write down the half reaction that takes place in A. So that's the one for barium. So remember, you don't write down the one that's there. You know, remember these ones are generic. That's the one that we got from the table. You write the one that you've actually adapted, so that you know which reaction is taking place. Please, ladies and gents, when you write it with one arrow. So that's barium 2 plus 2 electrons, and note with one arrow in this case, so that you show that it's actually undergoing oxidation, right? So 8.4. Okay, so we they say to us, write down the cell notation for the cell. Now, remember, there's a difference between a cell notation. This is what we call the net cell reaction. Okay, so this is the net cell reaction, or you can say the overall reaction. Okay, overall reaction. So the net cell, the cell notation rather, so you always write the anode on the left hand side. So remember, anode is barium, so it will be barium in solid form, which changes to, this means change in phase, right? The backslash there. All right, so barium 2 plus, okay, and which is in aqueous form. And by the way, you don't necessarily need to write these, okay. In this case, the double backslash tells us of the salt bridge. Okay, so now for copper, do you see it starts as copper 2 plus to copper? So that will be copper 2 plus. Okay, that's aqueous, and it is converted to copper, the solid. Okay, so that is our cell notation. All right, now let's look at the next question. They say calculate the EMF for this cell. Okay, so it should be actually the initial EMF, because it does change with time. Okay, so In this case, we say E cell, right? Please write down the reaction, or rather the equation, as it appears in your data sheet, right? So E cell would be equal to E cathode, right? E standard for the cathode minus the E standard for the anode. And in this case, that would give me, all right, so for our cathode, remember that's copper, that's 0.34 minus, remember that's a negative there, minus a negative 2.9, okay, 2.90. And in this case, when we add these, that's going to give us 3.24 volts. Okay, so our EMF for this cell is going to be 3.24 volts. All right, so next question, 8.6, right? So they say to us, how will each of the following changes influence the value of the cell's EMF, okay, as calculated in question 8.5, right, only increase, decrease, or remain the same. Now let's have a look at it. So first of all, they say ammonium sulfate is added to the barium nitrate solution. Yeah, so this examiner must have been thinking about when we used to do inorganic chemistry. In this case, of course, this is theory that you guys do not have. So honestly speaking, I'd say don't worry too much. They wouldn't ask such a question because obviously there's a part that we need to also know in for inorganic chemistry. So I've forgotten that part, by the way. So I wouldn't know whether barium nitrate, barium sulfate in this case, causes a precipitate or not. So I'd say forget about that question. Okay. All right. And then the next one says the temperature of the solution is increased. Now you must remember that the galvanic cell is largely an exothermic reaction, right? So once you increase temperature, you favor, remember you always favor the endothermic reaction, right? So if you think about that net cell reaction, at a point you're going to cause equilibrium, right? To that's why the cell actually, the EMF decreases with time. So anything that favors the reverse reaction will cause a decrease in the EMF. Anything that favors the forward reaction would increase the EMF. So if you think about an increase in temperature in this case, it will tend to favor the reverse reaction, which is endothermic. And so as a result, it means that our EMF would decrease with an increase in temperature. Okay. Please just remember that part, okay? Right. And essentially, ladies and gents, that is how the cookie crumbles. All right, so I'll see you guys again next time. I hope your preparation is going well. And please just keep going and using this content to try and aid yourself towards getting that distinction, right? All right, I'll see you guys again next time. Sharp, sharp.